Hi everyone, today we are going to make CFD analysis for this aircraft. So as we can see here, we have two control surfaces. We are going to use them as aileron and elevator at the same time. So to analyze the situation, we need to know what is changing. So we have this aircraft. Okay, what is changing? We want to make multiple CFD analysis. Why is that? Because the velocity is going to change with time. Maybe it's going to be between the range of 10 to 50. This is my aircraft. Okay, maybe for another aircraft it will be let's say 100, or maybe it's a rocket. It's going to fly at a faster velocity. For my aircraft, the velocity is going to be from 10 to 50. Because I don't have a lot of computers, I only have one, we are going to make for velocity 10, 20 to 50. Okay, so what we are going to have? We are going to have a velocity of 10, 20, 30, 40, 50. Okay, this is my velocities. And also we have another changing variable. It's the angle of attack, it's alpha. For me, I'm going to make from minus 24 to 24. Okay, and the changing between them is 3, 3. Okay, so each step we are going to we are going to add 3. Okay, so it's angle of attack, it's degree, this is meter per second. And also what we have beta, it's also going to change. So I'm going to make, let's say, from minus 12 to 3, okay, to 12. It depends on your aircraft. For me, this is enough actually, and I don't wanna spend a lot of time making CFD analysis, because this is going to take a lot of time. Every design point, we are going to have a lot of design point. So let's say at first we are going to make the velocity 10. Then for this particular velocity, we are going to vary the angle of attack. So it's going to be from minus 24 to 24. Okay. And then for each one of them, this is going to take a lot of time. So for minus 24, we are going to make for beta. Okay. For beta from minus 20, for minus 12 to 12. Do you see? This is going to take a lot of time. Now let me erase this. So we are going to see what is also changing. The control surfaces are also changing. So let me show you how. for example, we have this control surfaces. If it's elevator, okay, if it's elevator, they both are going to rotate. So for example, let's say the deflection angle of the elevator is 30. Do you see how it's going to be? But the rotation axis is going to be this. Let me show you which one. This is going to be our rotation axis. So the deflection of the elevator, let's say from this is the deflection of the elevator. It's going to be from -30 to 30. Okay. The step is going to be 5 degrees. Okay. So we are going to have -30, then 25, -25 to the 30. And also we are going to make this is going to be one analysis. Then this is going to be with the deflection of the elevator, we are going to vary the velocity. So also the velocity is going to be varying. The velocity from 10 to 50. Okay. This is also another analysis. And then we also going to, the aileron. Now we are going to capture the aileron effect. So it's also from -30 to 30. Okay. And we are going to take the velocity also in consideration. Sorry, wait a minute. This is we can't take all the velocities in consideration because we have from 10 to 50. It's a lot. We are going to take only two velocities in consideration, 20 and 50. Okay. And here also 20 and 50. So this is another discussion. And then we are going to investigate another thing. Which is the dynamic stability coefficient. Do you see this? This is all static. Okay? We are not investigating dynamic stability. Okay? This is all static stability. So let me erase this. We're also going to make dynamic stability analysis. What is the dynamic stability analysis? Let's say, let me erase all of this. Okay. At a particular velocity and a particular angle of attack. Let's take this, all of this. This is angle of attack 0, okay? for different angle of attack, let's say minus 12, okay, or positive 12, it's better. Okay, this is positive 12 angle of attack. If we said that the wind velocity is like this is the wind, it's going in this direction, okay. At this angle of attack we are going to get let's say lift coefficient CL, okay. But this coefficient is static, so let's say the aircraft is not moving or it's not rotating, so this coefficient is going to be true, okay. This is going to be accurate. For example, 1.3. This is just an example. But however, if this velocity is moving and rotating, not moving, if it's rotating like this, but about the center of gravity, okay, this is my aircraft. Here the aircraft at angle of attack, this is the velocity of the wind, V is equal to 10, okay. Here the angle of attack is at 0, okay. Now let's say, do you see, at angle of attack 12, this is at angle of attack 12, this is 0, this is 12, okay. So at angle of attack 12, which means this, it's 12, okay. Here the angle of attack is 12. Do you see that? Now the angle of attack is at 12. So at angle of attack 12, we said that CL is equal to 1.4. Okay, we said 1.3, but let's change it. 1.4. Okay. Now this, if the aircraft is not rotating. However, if the aircraft is rotating like this and then it reached angle of attack 12, then the lift coefficient is going to change. For example, it's going to be 1.5 or 1.3. I don't know how much, but it's going to change. And we call this CLQ. It means that the change of CLQ is equal to the change of the lift coefficient over the change of the angular velocity of the aircraft, the pitch rate. This is the pitch rate, and this can apply for all of the body, for all of the axes. Do you see? This is the x-axis, this is the y-axis, this is z-axis. So now let's get back. We wanna capture this change in lift coefficient. Okay, we want to know what is CLQ. So this is why we are going to make CFD analysis. So what we wanna do, we know that Q is changing. Let's say how much is the angular velocity? How much? Let's say 15 degree. What's that? 15 degree per second. Okay. And also let's make for another design point. Let's make it 45. If you have a lot of computers, I recommend you to make more design points. So, and also you need to consider the velocity. Velocity, let's make it 10, 20, 30, 40, 50. Okay. So, and what we are going to do, this is just for the pitch rate. We also want to take the yaw rate and roll rate, which are P and R, and also this is Q. Okay. There is one more varying variable. We need to varying parameter we need to take into consideration, which is alpha dot. Okay. There are a lot of people who misunderstand the difference between alpha dot and Q dot. To know the difference between alpha dot and Q dot, not Q dot, Q, they are both angular velocities. So they both have the unit of degree per second or radian per second. However, the difference between them, do you know we have forget about the aircraft for a minute. Let's say that this is the aircraft. Let's represent it as one chord. Okay, and this is the center of gravity. This is the CG, and this is the velocity of the wind. Okay. This is the center of gravity. Probably we are going to put to place. We are going to place the brain of the aircraft, or the GPS or accelerometer. The GPS not really important, but the accelerometer, the gyroscope. Okay, we are going to put it at the center of the gravity. So we have this. This is the chord of the aircraft. Okay, we have 3 points. This is the leading edge. This is the trailing edge of the whole aircraft. We are representing the aircraft as one line. Okay, and this is the center of gravity. We have what we said. We have the Bix hook at this point, and also we have the gyroscope at this point. Okay, because this is the center of gravity, because it's the center of gravity. So we wanna understand the difference between alpha dot and Q. What is the difference? They both are angular velocity. The Q is the angular velocity about the center of gravity. Okay, so if we have q, its rate, or its changing axis or rotating axis is this point. Okay, so we have what is the difference, why we wanna differ between them, because the alpha dot is the angle between the wind and the aircraft. Okay, so let's say let's forget about alpha dot for a minute, and actually no, let's take alpha dot into consideration and forget about q for a minute. We have the aircraft. This is the aircraft, and this is CG. This aircraft has alpha dot. What is alpha dot? Angular acceleration, angular velocity, sorry. It's angular velocity. About what? It's about the leading edge of the aircraft. Okay, so for example, we have this wind velocity, and we have this chord that represent the aircraft. Okay, let's put it here. This is the leading edge, and this is the trailing edge, and this is the center of gravity. Forget about the center of gravity for a minute. Let's say that this aircraft has an angular velocity of let's say 10 degrees per second. Okay, or whatever it is, degree per second. Okay, whatever it is, not important. The important thing is to understand what is the difference between them. So we have this velocity, and we have this aircraft, and it has angular velocity. Now let's put it at angle of attack. Okay, I'm not really good drawer. So we have this velocity. Okay, we have this velocity of the wind. The wind is blowing this direction. Okay, we have this velocity, or the aircraft is moving. Also, it represents the same thing. And this aircraft has velocity omega. Okay, so let's draw the velocity along this line. We have here, let's take any point, this point for example. Do you see? This point has a wind velocity of v. Okay, and also it has angular velocity of w. And to make to convert this angular velocity into linear velocity, we are going to take this distance, let's say x. Okay, so here the velocity because of w is going to be actually not like this, but forget about this. It's perpendicular to the chord. Okay, here is a perpendicular relationship. We have this x. We have this is going to be omega times x. Okay, So the velocity, this velocity is going to be constant along the line, but this velocity is going to be changing. Why? Because we are multiplying by x, and this x is increasing by distance. So here is bigger than here, is bigger than here. Okay, so let's draw the velocity along the line. Let's say that this is the line. Now we are going to draw the velocity profile along this line. So what we are going to do, we said that this velocity is constant. Let's say that it has any direction. It's not important. It's going to be like this. For example, it's really not important the direction. So this is going to be a constant line. Okay. However, this is not going to be constant. It's going to be linear. It's going to be to have a slope. Okay. So the velocity here, the angular velocity, there is an angular velocity, but the linear velocity is 0. Okay, so this is velocity of 0. Now here it's going to be, let's say, let's have 4 points. Okay, this x, and this is x, and this is x, and this is x. Okay, now we have 4 points. We can use them to draw the velocity profile due to angular velocity, but this angular velocity is actually alpha dot. Okay, now it's perpendicular, as we said. It's going to be omega times x, but here it's going to be double. Okay, this is omega times x, and this is the double, so it's 2 omega times x. Do you see? And if we continue, it's going to be like this, and if we continue, it's going to be like this. So it's actually a line. It's going to be a linear line, but it has a slope. This is the effect, or the velocity profile due to alpha dot. Okay. However, if we have q, it's also angular velocity, but here we need to be careful. This here we have angular velocity, but about this point. Okay. However, here, let's say here we have only q, and it is rotating about the center of gravity. Of course, this is going to be CG, the center of gravity, and here it's going to be x, and here 3x. Okay, for example, it's not a rule. Okay, this is just an example. As we said, the wind velocity is going to be constant. Okay, it's going to be constant. However, because we have a q, an angular velocity about the center of gravity, it's q. Okay, here let's see the linear velocity due to angular velocity. Because of this angular velocity, we're going to have here linear velocity, which going to be the value is going to be, let's say, like this, and its value is going to be q times x. Okay, here it's going to be 3 times x times q. Okay, so it's going to be not double but 3 times bigger. Do you see? Okay, so this is q times 3x. Do you see the difference between the profiles? This, let me put it red. So we have in this profile, it's different than this profile. This is the difference between alpha dot and q dot. Okay, so now I want to finish here. Okay, then we will continue.